The matrix is the premise that our universe resembles a computer simulation and that ours is an artificial reality. Here the Planck units are constructed from geometrical objects that then combine to form the matrix. If we could zoom down far enough, we would find the smallest possible distance between 2 points. This would be Planck length. Between A and B, there are 8 Planck lengths. We need 10 to 31 Planck lengths just to make 1 centimeter, and 10 to 62 Planck lengths to measure our universe. In this model, Planck length is a mathematical formula that describes the surface area of a torus. But it is not a physical torus. It is only a mathematical formula that can also be used to describe a torus. If A is here and B is there, and the distance between them is defined by these mathematical torus, then there is no physical distance between A and B, only this torus mathematical separation. And so logically, if there is no physical distance between A and B, then there can be no physical A and B either, only a mathematical A and B.
Do we have a deal, Mr. Reagan?
You know, I know this steak doesn't exist. I know that when I put it in my mouth, the matrix is telling my brain that it is juicy and delicious.
If we could zoom down far enough, then we would find the smallest possible unit of time. We call this Planck time. There are 10 to 42 units of Planck time in 1 second. This means that in 1 second, the universe clock has ticked 10 to 42 times. There are 10 to 62 units of Planck time since the universe began, and this equals 14 billion years. But this means digital time, that time doesn't flow continuously. Instead, time jumps in discrete steps. But jumping across time in a real universe, where time is continuous, would be considered time travel. However, this is how computers simulate time. And so evidence of a digital time could be considered as evidence of a digital program. For example, quantum gravity models require a digital Planck time and work at Planck length. In this model, Planck time is a mathematical formula that describes the circumference of a circle. Is a unit of time simply rotation? Can I go back in time? The answer is no. but the universe can. That part is easy. We just turn the clock back, but then our memory of the future would be lost. In this model, at the center of each particle is a single Planck-sized black hole. This black hole is the origin of mass. Photons don't have a black hole center to rotate around, and so photons will not have mass. The mass of an object derives from the sum of particle Planck black holes that comprise that object. A Planck black hole is equivalent to a hard disk sector and is where the information as particles is stored. The black hole is the interface between the matrix and the real world. Photons are the means by which information is exchanged between particles.
The Planck scale is such a tiny number that it is hard to wrap your mind around how small it is, but an analogy can help. If you were to take, say, an atom and magnify that atom to be as big as the size of the observable universe, that's a huge scale of magnification, then under that same scale of magnification, the Planck scale would turn into roughly the size of an average tree. So a tree is to the observable universe as the Planck scale is to an atom. That's how small it is, and that's why it's so challenging to observe any of the physical phenomena that we think may be taking place at the Planck scale. It's just so fantastically small.
In summary, we have the geometries of the Planck units. There is a set of relationships that links them together. But this means that mass, space, time and charge are not independent of each other. Instead, they can overlap and cancel to 1 in this ratio. But this also means that from 1 we can make mass, space, time and charge. This 1 turns out to be a formula for an electron, which means that from this electron we can make mass, space, time and charge. And then we can solve the physical constants. This is continued in part 3.